We're chugging along, chapter 5, section 7, where we're factoring special products. Whoops, that was going to work. There we go. But anyway, it's really the same thing. The only thing is the book wants you to notice patterns. For instance, as you look at factors of 64 that add to be 16, you'll notice that the values we're looking at are 8 and 8. So instead of them wanting you to write x plus 8, which is absolutely correct, nothing's wrong about that, what they want you to do is to write the answer as x plus 8 quantity squared. Because that's what it means to be squared, is x plus 8, x plus 8. But it's a special product. And you'll notice that as we move forward, the difference with exercise 2, though, is there's a greatest common factor first. And that factor is a 5 and a b. So then you're looking at 9x squared minus 6x plus 1. And as you work through this, and I'll let you work through it on your own, what you'll notice is that you'll get 3x minus 1 squared. And if I were to FOIL that out, 3x times 3x is 9x squared. Negative 1 times negative 1 is positive 1. The outside term would have been negative 3x. The inside would have been negative 3x to give you negative 6x. And so they're just special things as we work through this. What might help you with the next one is if you were to think of it as 25x squared plus 0x minus 49, and then work through the problem the same way. Where you can do, the outside, the inside, and work through it that way. However, this is something unique, which is called a difference of squares. Difference because of the minus. So this only works when it's a minus, a binomial, and these are both perfect squares. So how do you get 25? Well, you get 25 by 5 times 5, and you get x squared by x times x. And then how do you get 49 is 7 times 7. Now how do you get negative 49 is one term has to be positive and one term has to be negative. And it doesn't matter which one. So this is called, this is factorable with a subtraction sign because you want the outside and inside terms to cancel each other out. So you'd see you get negative 35x plus 35x, which is 0x. So that's why I think it's helpful to see that. Otherwise, you just get stuck in this rut where students just memorize, the greatest common factor of this one, because that's what 3b is 5. And you're looking at 9 minus 4x squared. And then students tend to memorize, a binomial, perfect squares, and a difference. So then they say, okay, well, 3 times 3 gives me 9. 2x times 2x gives me 4x squared. And how do we get a minus? Make 1 plus, make 1 minus, and that's our final answer. But there's more to it than that. The only thing is a lot of students just memorize. So feel free to pause the video before I move on, because that's just what's happening here and here. Is as you notice, there is a perfect square. It's x squared times x squared to give you x to the 4th. And 10,000 is a perfect square. If you hit the square root of 10,000, you'll get 100. Now here's the thing. Sometimes when you factor, you get another difference of squares. So the expectation is that you continue to factor. Now notice this is a sum of squares. It's a plus sign, so you can't do anything with that one. But this difference of squares you could rewrite as x times x gives you x squared, 10 times 10 gives you 100, make 1 plus, make 1 minus, and now you have the most factored answer. I need you to factor all the way down. So there you go. Same thing goes with the next one. I'll change colors just to change it up. Is x plus 2 would give you x plus 2 squared. To give you 49, it's 7 times 7. Make 1 plus, make 1 minus, and you have the right answer. Now, I'll accept it like this, just because that's what I'm trying to get you to understand. But the back of the book might actually simplify. 2 plus 7 is 9. 2 minus 7 is negative 5. Hopefully I did my math right there as well. We can do more grouping. That's what the exercise 5 is. I believe this is grouping. If I remember off the top of my head. No, it's not. You can see why I would think it's grouping though. But if you notice, they actually want you to think of it as a difference of squares. Why? Is the first 3, if you were to factor that, is m plus 3 squared. And then this is just n squared. So you can see from that you have a difference of squares. M plus 3, m plus 3. N and n make 1 plus, make 1 minus, and you have a good factored problem. The next one is what's called a sum of cubes. And you may have heard something called SOAP before. S-O-A-P. SOAP. Same, opposite, always positive. That's what SOAP stands for. So what you'll want to identify is what cubed will give you 64. And you can use your calculator and investigate that it's 4 cubed. So how you write your answer is x4, and then you write x squared, then you multiply 4x, and then the last term is 4 squared, which I'm going to write 16. That's 4 squared. So where does SOAP come in from? Is this sign right here. It's the same sign, so plus goes here. Right here is the opposite sign, so it's minus, and right here is always positive. If you spell out SOAP, S-O-A-P, same, opposite, always positive. And you probably did this in Algebra 2. You may not have heard this acronym before. So we can do this for a difference of cubes as well, which is actually right here. It's a difference of cubes. I recognize I'm probably going fast, but if you remember this from Algebra 2, that's a good thing. And what would be important is to recognize that this is a cubed plus 2b cubed. So as you write it out, a, 2b, and then a squared, and then 2ab, because you just multiply them together. And then it's 4b squared, because you have to square both the 2 and the b. Same sign, opposite sign, always positive. There's that answer. So let me change colors and look at the next one, because 3 cubed is 27. All right, let me just write it down here. You have 3y. Now I'm going to write 9, because 3 squared is 9. 3y, and then y squared. Same sign, it's minus this time. Opposite sign, and then always positive. Please don't forget, you can always check your work. Check by distributing. If you distribute it out, everything will cancel, or things will cancel, and you'll get down to this piece up here. And then we just have one more twist, is a greatest common factor. It's exactly what happens here, is x cubed, and then b cubed minus 2 cubed, because 2 cubed is 8, and we factor out that x squared. So don't forget about that x squared in front, but then you can write b2, b squared, 2b, and then 4, because 2 squared is 4. Same sign, opposite sign, always positive. And if you FOIL that out, you will get back to the original problem. So I'm well aware I worked through these really, really fast. So feel free to write things down, rewatch the video, and come to class with questions. There's your homework.